Okay. All right. So we're still talking about congruency. This is the last day of it. We're going to be moving on to the next section, which is 4.4 tomorrow, which is proofs. And that's something I was hinting at, that we're going to be starting to talk about how to prove, geometry properties, prove that these triangles are equal and all that good stuff. So there's going to be quite a few properties tomorrow. So it'll be more of a kind of a PowerPoint kind of style where you just have to take a bunch of notes tomorrow. So we'll kind of see how that works. I may have a Google question of the day on Wednesday and maybe another one later this week, but kind of keep that in mind. I think we're supposed to get some weather tonight, like late tonight, so check the weather tomorrow just in case we're delayed or anything. It's not a lot of snow, not like Ankeny area where they're getting like 12 inches today or some stupid number like that, but we're supposed to get a couple inches, so check the weather tomorrow just in case we're delayed or something. So, but that's late tonight, so. All right, but yeah, so we're talking about congruency, that certain objects are equal. We're going to assume that all the pictures I give you today in your homework are the same. That's in the instructions. And you're supposed to set up, set the problems up so you can solve for X, solve for Y, and all that good stuff, with what you're provided. So I have a select few problems kind of picked out today. So one of which, the directions got cut off. So I'm going to have to use your book and use the same directions the book had. So I pulled a couple of these just from the example problems. So I thought that was pretty easy. But this first one I made on Friday. I just didn't give it to you. So here's our first one. I'd like you to write this one down. We don't necessarily have to do all my examples. And no, I don't have 12 examples. Some of these slides are from last week. I just didn't delete them yet. I have, I think, 4 examples kind of picked here. We necessarily don't have to do all 4 of them. Maybe we just do a couple, 1 or 2, until you're kind of familiar with what you need to do. Now, this first one in particular is a system problem. I want to make sure we solve it as a system, and then we'll kind of go from there. So the big thing here is that it gives you what triangles are congruent to each other. So this is, I want to do at least one system and then do one problem where it's kind of real basic, real simple. You will have systems in your homework today, so just be aware of that. So you'll have to be able to set them up and solve them and know how to do your systems, with the elimination method or substitution method. So there's a few. Yes, you will get decimals today, so don't fear that every number will be nice and clean. I think this one's nice and clean, the way that I created this one. So. But I want to do at least one system and then one problem where it's just kind of normal, where it's some easy numbers. So I'll let you write it down here. Basketball games this week. I think we have a game tomorrow at Bishop Garrigan. Then we have Friday's a pink out night. It's coaches versus cancer. And then Saturday, I think, is at Newman. Wrestling this weekend, how'd we do?
I don't know.
No idea? Okay, all right. So wrestling happened this weekend, and obviously I think it's this week, Thursday this week. I think you're at home. So.
Wait, if the game's at Newman, we can go, right?
I don't know.
Because it's on that side of the
yeah, I don't know. I'll find out. I'll let you know. So that's Saturday. Yeah, I'll let you know. I'll find out today. I'll ask Ryan. So I don't know. I don't know the rules over there.
Because I know when Lake Mills played at Osage, you could go because they were on that side of the conference.
Interesting. I'll find out. It's interesting. That'd be nice to have a crowd again. All right.
55 or 56?
That's a 58.
Oh wow.
Yeah. Here, you want me to zoom in? It's a 5.8. Just really bad penmanship. There you go.
Okay, we not know.
Okay. All right, let's kind of set this up. So the big thing here is, obviously they're giving me a bunch of angles. So I can obviously tell like one of these angles for sure. Angles C and D are the same. Now there's a couple different things that give that away. It's because of the letters up here, right? C and D are the last letters on the that part where it says the congruency. This triangle is congruent to this thing. But also from the picture, they have the little bubbles. So I can transfer that 58 over to here. So that 58 degrees can hop over. So that's kind of an obvious thing. They got a couple things there. The big thing is using that congruency item that's printed at the top. You should try to always use that. Always use that object. It's really easy. I always do angles first, then when you're exhausted the angles, and go after the walls and go from there. So we're going to keep going because it looks like everything in this picture is just based on angles. So let's try to set these up. So we got C and D. I didn't really need to use it. Actually, I could use it here in a second to figure out the missing angle here, because we have 2 angles of a triangle that are given to me, so I could figure out the third one. So we'll do that here in a second. Angle A and F are the same. Okay, so I'll try to color code these. Angle A and F are the same. They're the front letters. So this is angle A, that's angle F. I can set those equal to each other. So 3x plus y is equal to 97. Okay, questions on how I set that up? Now, the other angle is B and E. B and E. Let me get rid of some of these markers here. So B and E. Let me put it in a different color here. This is angle B, this is angle E. They're the middle letters. They're supposed to be equal to each other. Now, here's the question. I don't have anything printed for angle B. But how do I find it? Or angle E, I guess, in this case. How do I find that angle? What can I do? How do I find the number for angle E? What do triangles add up to be? 180, right? That's our first theorem we had way back in section 4.1. Since a triangle has to add up to be 180, I can figure out what angle E is because you take 180 and you subtract these other two numbers, 58 and 97. If you take those angles away, I can figure out what angle E is, and that's the same as angle B. So let me do that in my calculator here. 180, I'm going to take away the 58. I'm going to take away the 97, and it leaves me with the 25. So this angle here is 25 degrees. And that's the same as this angle down here. This is 25 degrees as well. Again, now how I did that, just so you know. Took 180, subtracted the two angles they provided me, and that's what gave me that third angle there. So, all right. So let's set that up. So what do we have? We have an x minus y. X minus y plus 2 equals 25 degrees. All right. All right, questions on the setup. I haven't solved anything yet. I basically just got the setup here. If I'm going to do elimination problem, I'm probably going to do that. How do I get rid of that 2 on that blue line? What do I have to do? What can I do with that 2? Please.
Move it to your side.
Yeah, what happens if I move it?
Subtract it.
Subtracts. All right, so we're going to move it over. We're going to subtract it. So the 3x plus y equals 97. That's going to stay the same. If I subtract the 2 across, I'll get x minus y equals 23. I'm going to subtract that 2 across. So now we're in an elimination method. Now we got the things lined up. They're perfect. What letter should you pick? Say it? Somebody said it, didn't I? Oh, I should just be hearing things. Sorry. Why? Okay. Why should we pick the y's?
Because the signs are different.
Yeah, the signs are different, and they're already the same number. It's perfect. You don't even have to do any work. They're already ones, and the one's positive, one's negative. In fact, I'm going to put that little number in there. So one of them's already positive, one's already negative. So there's a 1 and a 1. So I can just add these straight down, and when I do that, the y should cancel out, and that's what you want to have happen. That you want to have one of the letters eliminate. Now, if they weren't the same number, you can make them the same. Just, multiply one row by a number and multiply the second row by a different number. Get them to be the same, but they're already the same number. So if I add straight down, what's 3x plus 1x? 4x. And 97 plus 23, what is that, 130? Is that what that is? 97 plus 23? 120. Oh, man, I'm really bad at adding. 120. Now what? Divide by 4. Right, divide by 4, divide by 4. X turns out to be what, 30? Is that right? 120 divided by 4? 30. So that's a nice clean number. Now what should we do with it? What should I do with that? What should I do with that 30 now?
Plug it back in the second column.
Yeah, plug it back in, right? Plug it back into one of the two remaining equations. It could be any of these two, right? Plug it back into one of these two. It doesn't matter which one. But you have to plug the 30 back into the x. It doesn't really matter which one you pick. If you want to pick the second one, that's fine. I can do the second one. And we'll plug it back in. It has to go into the x location. We'll solve for y. So, all right, yeah. Let's plug that back. Let's plug that back into that blue equation. So, I have the x minus y plus 2 equals 25. I'm going to plug that 30 back in. It goes into the x. I didn't have to do anything fancy on this one. It's pretty straightforward. I'm going to move the y across, move the 25. I think that's the fastest way to do this to solve. So if I move the y across, it becomes positive. If I move the 25 across, it becomes negative. So I have 30 minus 25 plus 2. That makes sense how I moved everything around. Move them across equal sign, they become opposites. So it looks like, what is that? 5 plus 2 is at 7. So y is a 7 for that to work out. And yeah, it works out for the green one as well. So if I plug in my green equation, 30 and 7, it still works out to be 97. So yeah, pretty good check. But that's what you're doing today. So you're going to have to do a system. You'll have to, set it up. You might have to rearrange the system like I did, right, to move the 2 across, get them like kind of in that standard position where the x's are lined up, the y's, equal signs, and the numbers, and then you can go ahead and solve. You will get decimals. So don't feel like everything's going to be a nice clean number. It could be decimals, so don't fear that. Questions on this one, though? Pretty good. I want to do at least one system. I think you have at least a few of these today, so be aware of that. I think total problems you have today, I think you have 6 problems. I think there's at least 2 of them that are systems, so be aware of that. You're going to have to solve it, find x and a y. All right, let's do one more. Let's do kind of an easier one. Something, because we don't need to have to do all these challenging ones every single time. Yeah, let's do this one. Let's do the second one here that I had picked out. All right, now this is the one where the instructions got cut off. I'm sorry. Let me put the instructions up above. All right, so on this one it says triangle LMN. Yeah, there. I'll turn off that so I don't get any notifications here. All right. All right, so triangle LMN is congruent to triangle, I think it's SRQ, it's QRS. Okay. So this is the instructions. Sorry I got cut off. I just took a picture of it from the book. Didn't have the instructions above it. Goal is still to find x and y. So on this one, I'll do the angles first. I always like to do angles first so you can see them. It looks like on this particular case, the angle M and R are the same angle, so that's this one and this one. Well, it's kind of obvious. Don't read into it too much. Don't be like, well, those are the only ones that have Y, so I'm going to set those equal. Don't do that. Don't make those common mistakes. I saw a couple in the book where they threw a couple X's in the problem, but those weren't the walls you set equal to each other, just to throw you off. You had to set it equal to a different wall so you could solve. The X's just happen to end up being the same number throughout the problem. It's just you didn't set them equal to each other. So be careful of that. But on this one, you do have to set those two terms at M and R equal. So y plus 10 is equal to 2y minus 40. So I set those equal to each other and solve. How do we solve that? Somebody walk me through it. What do we do? Pretty straightforward. This will be my last example of the day here. But what do we have to do? So please.
Move the 10 on the other side.
Okay.
Move the 2 on the other side.
Yeah, so if we move the 10, it becomes negatives, and negative 40 minus 10 more. And we're going to move this 2y across, so it becomes minus 2y. That's fine. You could have moved it in the other directions. It's fine. It's the same answer no matter what. I like this. Now, when we do the math here, what do we get? We get a negative 1y, negative 50. It's negative 40 minus 10 more. And then what? Then what do we do? Negative 1y equals negative 50. Please.
You divide them by -1.
Yeah, divided by -1, divided by -1. Basically what it does is it cancels out the negative sign, so your y is a 50. Boom. Got our first letter. No system on this one, you're just solving. On a single variable, you just have to know your algebra 1, solve. Hopefully this is pretty easy. Hopefully you're just finding this kind of mindless. All right, let's go to the next one here. So we're going to go to the next part. Now these are walls now. I've done with all the angles. There's no more angles in the picture. Now I have walls. I'm just going to double check that these walls can be set equal to each other, because maybe I can't solve for x. Maybe I don't have enough information here. I think I do. So on this one, I'll try to color code here. They're giving me wall LM. That's this wall over here. That's LM. That should be equal to QR on the other side. Letter for letter. Walls are always 2 letters. So you could either do the front 2, the back 2, or the outside 2. So I'm going to do the front 2, LM and QR. And QR is over here. So it does make sense. I can set those equal to each other. So 2x plus 11 is equal to the 3x minus 9. Then you go ahead and we solve from here. Same exact work we just did in the last one. In fact, I'm gonna do it the exact same way. In fact, move the 11 across, move the 3x across, so 2x minus 3x. Subtract the 11 over. We get a negative 1x equals negative 20, and divide by negative 1. X turns out to be a 20. All right, questions, comments, concerns about any of the problems we've done up to this point? Now, if you want, I'll leave up that system problem if you want me to go back. If you want me to do another one, I'll do another one. I got 2 more problems kind of picked up from the textbook. Unless you guys feel comfortable. You guys need any extra problems, or are you guys good to go? Take it out, we're good to go. Okay. Google question went live. I think it's a worksheet. It's due this Wednesday. It's 6 problems, I believe. You have to solve for the variables in the problem. Maybe your variables are A, B, and C. Maybe they're X, Y, and Z. Maybe it's a system. You just have to type in your answers. You know, X is this, Y is this. Submit it. Make sure you're logged in with your GHV school account so that, you know, it gets the correct name on there. So you get credited for it.
Can I get a water?
Yeah. I have it charged, actually. Freshly charged one. Yep. All right, but there you go. Stop the recording here.